When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to one of the past HSC exam question videos. In this video we're going to cover this exam question, which comes from the Theory of Bases and Acids chapter. I'll do in a second, I'll cover this, I'll read this question. Once I read the question, you get about 5 seconds to pause the video. Once you pause the video, attempt the question, and then press play when you're ready again. This says, you perform the first standard investigation to identify the pH of a range of salts. A. Identify the acidic salt you used, that's worth 1 mark. And B. Explain the acidic nature of the salt you selected. Include a balanced chemical equation in your answer, and that's worth 2 marks. So when you're ready, press pause and attempt the question. Welcome back. Alright, so for this question, the first thing is identify the salts that you used. I mean, again, it depends. We can mention any salt that you used in the experiment. I just mentioned ammonium chloride because that would be one salt you could have used that was acidic. Right, so ammonium chloride, and I just wrote the chemical formula as well, NH4Cl. This is our acidic salt we used in the experiment, and that's for 1 mark. So for the next part, for B, explain the acidic nature of salts you selected. Include a balanced chemical equation in your answer. So this balanced chemical equation should show why the actual solution is acidic. That's what your chemical equation should show. And you should talk about your actual 2 things that make up your acidic nature of the salt. So your weak ammonia, in this case, you have a weak ammonia, which produces the ammonium ion, so weak ammonia, which is our base. And we have a strong acid, which is our hydrochloric acid, and that forms our conjugate base. So you should talk about the ammonia and the hydrochloric acid and their respective conjugate acids and bases, which form the salt, and then how all this leads to the fact that we have a acidic salt. So what I wrote first is ammonium chloride salt will dissolve in water into its respective ions. So into ammonium ion, into chloride ion. So that's when it touches water. So when they come in contact with water. That's the first, just a general statement of what happens when you put salt into water. They turn into their respective ions. Then I talked about chloride ions and how they're really weak. I should actually have written chloride, not chlorine. Chloride ions are the very weak conjugate base of hydrochloric acid and will not be looking to accept a hydrogen from the surrounding water and reform hydrochloric acid. So they're so weak that they will not do anything. Once they go in solution, they'll stay the way they are. They're not going to change, which means we don't have hydrochloric acid reforming. Because if this were to happen, if hydrochloric acid were to reform, and if our chlorine ion were to accept a hydrogen, so if this were to happen, then the water molecule that lost its hydrogen ion would turn into a hydroxide ion, and the pH of the solution would increase. So if this were to happen, then our pH would actually be higher than 7, it would be basic, but since this doesn't happen, the solution won't be basic. So we talked about chlorine ion, how it's very inactive, and then we'll talk about the other one, which is the ammonium ion. The ammonium ion is stronger, as is the conjugate acid of the weak ammonia base, or the weaker ammonia base. So we have a stronger conjugate acid compared to the very weak conjugate base of the chlorine ion, or the chlorine ion being the very weak conjugate base. So it's a stronger one, and what that means, it will be more likely to act as an acid and donate a hydrogen ion to water. So it's more likely to do this, it's more likely to donate a hydrogen ion to water, which means it's going to reform ammonia. And obviously reforming ammonia is not actually the main part, but obviously the other part is the main part, and this is what I wrote here. When this happens, the level of hydronium ion will increase, which will result in a slight drop in pH. And this is our equation, ammonium ion plus water, and then ammonium ion donates a hydrogen to the water molecule, which means we have NH3 reforming. This is ammonia is reforming. This is not the violet part. The violet part is because this has accepted a proton. We have hydronium ions, which now have re-established themselves. And obviously hydronium ions will lower the pH, which means the solution itself will be slightly acidic because of this conjugate acid, ammonia, reforming some ammonia. So the conjugate acid ammonia ions, ammonium ions, will reform ammonia, and by doing so will decrease the pH, as it also means we're going to have some hydronium ions being reformed. And what I wrote, that's my last statement. So here this was worth only 2 marks, so you get 1 mark for mentioning that the chlorine ion does nothing because it's very weak, and you get 1 mark for having the actual equation, plus just saying that the ammonium ion will actually donate a proton to the water molecule and thereby produce hydronium ions, which will decrease the pH. It's worth 2 marks out of 2. And the other one, identify salt. All you need to write is the salt. That's also worth 1 mark. So here we've got 3 marks out of 3. And where does this question come from? It comes from these 2 dot points. Choose equipment and perform a first investigation to identify the pH of a range of salts in solution. That was question A. And question B comes from this dot point. Identify a range of salts which form acidic, basic, neutral solutions and explain their acidic, neutral, basic nature. So it's the explain part, which is what you had to do with B. But hopefully that was useful.
Thank you for watching.